Welcome to the November 24 GCSE from Edexcel. This is the first of three papers, the non-calculator paper. All right, question number one, carrying out the division. To make it a little easier, I've written it as a fraction and multiplied the top and bottom by 10, dividing the top and bottom by 2. We can write it as 4,092 divided by 6, and that's a calculation that we can do doing the bus stop method. There are multiple correct ways of doing this particular question, so anything that works is good. 682 is the correct answer for that one. Question number two. So discrete random variable, whenever you're dealing with the discrete random variables, the probabilities will sum to 1. I'm going to call the two probabilities for 1 and 2x, and then add together all of the probabilities and equate them to 1. Collect like terms, 2x plus 0.7 equals 1, so 2x is equal to 0.3, x equals 0.15. Multiplying 0.15 by 100 gives us an expected number of 75 twos for that one. Changing the probabilities means that we would expect to get more 2s if you increase the probability of getting a 2, and so the estimate will be higher. Question number 3, subtracting fractions. First thing I'm going to do is turn them into top-heavy fractions, so rewriting 3.5 as 7 over 2, 1 1/6 is 7 over 6. Find common denominator. 6 is going to be the simplest common denominator. 7 over 2 is the same as 21 over 6. Subtract the numerators and simplify. Turning it back into a mixed number, 2 2/6 or 2 1/3 once fully simplified. For the division of fractions, starting off in the same sort of way, turn them to top-heavy fractions. I'm going to flip the fraction we're dividing by and multiply. I'm going to show the cancellation of the 21 and the 7. Cancelling before multiplying just makes our life a little bit easier. And that's equal to 9 over 4, which is 2 1/4, which is what the question wanted. For the parallelogram, we know that AB and DC are parallel and that AD and BC are parallel. That allows us to write angle ACD as E because it's alternate to CAB. So that angle ACD is also going to be E. It's alternate angles. And therefore, we can work out angle CAD by subtracting the two other angles from 180. So we've got an E and a 3E, subtract that from 180, and our expression for CAD is 180 subtract 4E. It does say to give a reason, so always err on the side of caution. I'm going to put in that the angles in a triangle will sum to 180 degrees because that's the reason I have used. So 180 minus 4E for question 4. Question 5, we've got a car travelling at basically 5 miles an hour for 5 miles, at a speed of 30 miles an hour. So 5 over 30 is the same as 10 over 60 to turn it into minutes, so it's going to be 10 minutes. For B, because we rounded the 4.96 up and the 30.4 down, essentially we're dividing a larger number by a smaller number, which is going to give us a larger answer. Therefore, the 10 minutes is an overestimate. Something that shows that you understand that the 4.96 going up, the 30.4 going down gives a larger calculation will do. All right, question number 6. So we're dealing with a polygon. We know that there are 5 sides in the polygon, so it's a pentagon. Sum of the interior angles of a pentagon will be 540 degrees. If you just know that, that's fine. If you need to calculate it by subtracting 2 from the number of sides and multiplying it by 180, or 3 times 180, that's fine. And it gives us all the angles, either in terms of A or as angles themselves. Collect all the like terms. 7A plus 155 will be equal to 540. Subtract 155 from both sides. Divide both sides by 7. And we get A to be 55 degrees. For question number 7, the gradient of that graph is going to tell us the rate at which the water leaves the tank. Anything that mentions rate or the volume per second is absolutely fine for that one. Question number 8, we know that pressure is equal to force over area. The pressure is 80. The force is 720, so 80 equals 720 over the area of the base. Multiply both sides by A, divide both sides by 80. We get that the area must be 9 square meters, and so 2 multiplied by the length is going to give us that 9 square meters, because it's a rectangle, so divide 9 by 2, we get 4.5 as the length of the prism. Question 9. So we're doing a box plot. The critical values, interquartile ranges are going to be at 15 and 45, the median at 30. Because they've lined this one up quite nicely, you can't leave your ruler vertically and then continue drawing the line below if you want to. I draw the 5 vertical lines first at the critical points, then they've got the lowest value and the highest value there, and then draw the horizontal ones to give us the box shape like so. There you go. We need to test if Cyan is correct. So there are 42 that the 40 mark. So subtract that from 60, works out that there are 18 out of the 60 who passed. So 18 60th simplifies to 3/10. Times that by 100 to work it out as a percentage, it's 30%. So Cyan is correct. I assume that's Cyan and not something like Shan or something else. Apologies if it's not Cyan. All right, 25 to the power of a half is 5. So the square root of 25. 8 to the power of a third is 2, cube root of 8, so 5 times 2 is 10. The fifth root of 1 over 32 is a half, and a half cubed is an eighth. For question number 11, Kate unfortunately has got them mixed up. The sum should be 5 and the product should be 6. If I had £1 for every time I've seen that mistake, I would be a millionaire. For the full factorisation for B, factorising out the 2 first and then spotting we've got the difference of 2 squares. So it's going to be 2 lots of m plus 1 times m minus 1 for the full factorisation there. For C, I'm going to factorise the x out of the first 2 and factorise the y out of the second 2. Take the negative y because then we get a plus b in both. Factorise out a plus b from both, a plus b times by x minus y for C. Question number 12. This was to do with scale factors of volume, scale factors of length, scale factor of areas, etc., etc. It gives us a scale factor of volumes between A and B, 64 to 125. To jump from the scale factor of volumes to the scale factor of lengths, we need to cube root both of those. Cube root of 64 is 4, the cube root of 125 is 5. So the scale factor of length is 4 to 5. We know C is 50% in terms of its radius, so that's the length. So B to C will be 5 to 2.5. C is half the length of B. I'm going to double those to make them all integers, makes the calculations nicer. To turn those into scale factor of areas, we square them, so 64 to 100 to 25, and so the ratio of A to C when it comes to surface areas is 64 to 25. Question 13. we can construct a big equation. The volume of A, the three lengths multiplied together. Then the volume of B, we've got the three lengths multiplied together, add 142 because A is 142 centimetres cubed greater. And then it's an exercise in expanding, so I'm just going to pick pairs and expand them out. It doesn't matter the pairs that you pick as long as you do so carefully and correctly. I multiplied out the x plus 3 times x minus 3 because it's the difference of two squares. Gives me x squared minus 9 on the right hand side. And then multiply everything else out. Now what's nice about this equation is when we subtract 2x cubed from both sides, it's going to cancel them out, leaving us with a quadratic equation. With quadratic equations, of course, we want the three-term quadratic equal to 0, so I'm going to bring everything onto the left-hand side. It's always nice to start with a positive. Coefficient of x squared factorises to x plus 20x minus 7. So we can read off the solutions x equals negative 20 or 7. Of course, you cannot have a negative length, so I'm going to eliminate x equals negative 20 and select x equals 7 as the solution. Question 14, sine rule. So we've got AB over sine 45 will be equal to 3 root 2 over sine 30. Multiply both sides by sine of 45, so AB will be 3 root 2 times sine of 45 over sine 30. And sine 45 is root 2 over 2 and sine 30 is a half. So I can replace sine 45 with root 2 over 2. I can replace sine 30 with a half. And then go about simplifying the fraction. The root 2 times 2 is 2, cancels with the other 2, leaving us with 3 at the top. Divide 3 by a half and we get 6 centimetres for the length AB. So for the vectors equation, we know that O to M to M to Y is 1 to 3, and O to N to Z is 1 to 2, so I'm just going to mark those on there. O to Y is the A and O to Z is the B. Alright, let's start by calculating x to n. The pathway to get from x to n is to go from x to y, from y to O, and then from O to n. X to y is b, y to O is minus a, and O to n is 1/3 of O to z. O to z is b, so I can replace my 1/3 of O to z with 1/3 of b. Full simplification then, we get minus little a plus 4/3 of b. That's my x to n. For my m to n, the path to go from m to n, I'm going to go from m to O and then O to n. That's certainly the most straightforward way of doing it. M to O is minus 1/4 a, O to n is 1/3 b, and there's my vector m to n. The question wants a ratio of x to n to m to n. So x to n we've calculated to be minus a plus 4/3 b, and m to n we've calculated to be minus 1/4 a plus 1/3 b. At this point you can jump to the answer. I'm just going to do a little factorisation of the left hand, the x to n vector. Take 4 out, and that way you can see quite clearly we've got 4 lots of minus 1/4 a plus 1/3 b, and therefore the ratio is going to be 4 to 1. Question 16. 16a is straightforward, rationalising the denominator multiplied by root 5 over root 5. The numerator is 15 root 5, the denominator is 5, and of course 15 over 5 is 3, so it simplifies to 3 root 5. For b, I'm going to make my life easier by simplifying root 75 at the front. So root 75, root 25 times root 3 is 5 root 3. So I'm going to rewrite the fraction as 5 root 3 subtract 2 all over 1 plus 2 root 3. And then to rationalise the denominator, I'm going to multiply by the conjugate pair. So I'm going to multiply by 1 minus 2 root 3 over 1 minus 2 root 3. For the numerators, just carrying out a double bracket expansion, 5 root 3 minus 30 minus 2 plus 4 root 3. And on the denominator, we're going to get 1 minus 12. Collect all your like terms, we get minus 32 plus 9 root 3 at the top and negative 11 at the bottom. That's absolutely acceptable as an answer. I've multiplied the top and bottom by negative 1 just to make it look slightly prettier. 32 minus 9 root 3 over 11, but that wasn't necessary for the marks. Alright, question 7, the circle theorem. It's going to start with BAC. We've got our BCD being 40 degrees. BAC is going to be 40 degrees as well. That one's the one that everyone forgets, the alternate segment theorem. It's, some describe it as the least obvious of the groups of circle theorems, but the alternate segment theorem tells us that BAC is 40 degrees. We know that BAO is 3 times bigger than OAC, so I could call one of them 3x and the other one x. And if we add those two together, x and 3x, then we'd get 40 degrees. Just an algebraic way of working them out. 4x is 40, so x is 10, 3x is 30. So those two angles split up into 10 and 30. Given that OAB is 30 and OAB is an isosceles triangle, we know that ABO will be 30 degrees as well. OA and OB are, of course, radii of the circle. That's why I know it's isosceles. And my reason there is base angles in an isosceles triangle. Then to work out AOB, we need to add the two angles in our triangle together and subtract them from 180. So it would be 180 subtract the two 30s added together, which comes out as 120 degrees. Now it says write down any circle theorems that you use. I've just erred on the side of caution and written down whenever I've done some logic using a theorem or using facts, so I'm just writing them all down. So angles in a triangle sum to 180, and then angle ACB, that is a circle theorem. Angle ACB is going to be half 120, it's going to be 60 degrees, and that's because the angle at the centre is twice the angle at the edge. If you've reversed that and said the angle at the edge is half the angle at the centre, that's absolutely fine as well. You can even throw in some fancy words if you want to. The angle subtended at the centre is twice the angle subtended at the edge. It's not necessary for the marks, but a bit of flowery language just for fun. Lastly, to answer the question, angle ACD, well, we're adding together our 60 and 40. So it comes out as 100 degrees. Question number 18. We're given f of x and asked to find f inverse. I've swapped the x's and y's, you don't have to do that, but I've done it anyway. Make y the subject now, so multiply both sides by 4, add 3 to both sides, and divide both sides by y. 4x plus 3 over 5 is my inverse function. For b, we want to find the value of g of h of x. Rather than constructing the function g of h of x, I'm just going to substitute 5 into h. and then substitute, get negative 9 out, substitute negative 9 into g, and that will find g of h of 5, which is 100 in this case. Alright, for the chess tournament, work out the probability player A wins the chess tournament. Well, he needs to beat B, so 0.6, and then to face C would need to win against D, it's 0.2, and then A would need to win against C, it's 0.5. The other option is that D beats C, which is 0.8 chance, and then a 0.3 chance of A winning, and multiply those two, add those two possibilities together, A to be 0.204. Question 20, you're going to have to put up with my little sketch. It's not the best, but there we go. There's my circle, it's centered at the origin, and it's got a radius of 2. And there's the line that we're trying to construct the equation for. Alright, a bit of Pythagoras. We know that p squared plus 1 squared will be equal to 2 squared, or 4. So p squared equals 3, p is going to equal root 3. So the point is root 3, 1. We can use that to work out some gradients. So the gradient of the radius, that line that's passing through the centre of the circle up to the point P1 is going to be 1 over root 3, and therefore the gradient of our line, which is perpendicular to it, tangent is of course perpendicular to a radius, gradient of our line L is negative reciprocal 1 over root 3, which is negative root 3. Y equals mx plus c. I'm going to use that to find the equation of the line. We know it passes through root 3, 1, so I'm going to substitute y to be 1 and x to be root 3. Solve the equation to find c. We know that c is 4. And so the equation is y equals negative root 3x plus 4. Rearrange it, y plus root 3x equals 4, and we are done. Well done if you got that one. Bye.